Okay,
Yes, sir.
simple pulse coded modulation. It is a digital modulation process. PCM is a digital modulation technique. So this pulse coded modulation consists of transmitter and the receiver. Okay, and the in between we have the transmission path. Okay, so transmitter consists of low pass filter, sampler, quantizer, and encoder. Receiver consists of regeneration circuit, decoder, reconstruction filter, destination user. Okay, so next PCM. Okay, so PCM, as I told earlier, PCM is nothing but pulse coded modulation. Okay, it consists of three steps to digitize the analog signal. Okay, so three steps. First step is sampling. Second step is quantization. Third step is binary encoding. Okay, sampling, quantization, binary encoding. So PCM basically consists of three steps. Okay, so that is sampling, quantization, binary encoding. Okay, so before we sample the signal, we have to filter the signal to the limit the maximum frequency of the signal as it affect the sampling rate. Okay, so before doing the sampling process, okay, to convert the analog signal into the digital signal, first step we need to follow is sampling process. Sampling process. So that sampling process can be first step before we continuing the sampling process. First step is we have to filter the signal to limit the maximum frequency of the signal as it affect the sampling rate. Okay, so this next the filtering should ensure that, so by doing this filtering we to ensure that we do not distort the signal, just we remove the high frequency component that is affect the signal shape. That is why we are doing the filtering the signal, okay, to limit the high frequencies component which is affects the sampling process. Okay, so that is the first step. Okay, the sampling PCM consists of three major steps. One is sampling, another one is quantization, another one is binary encoding. Okay, so next is sampling. So sampling, you know what is sampling. Okay, so sampling is nothing but the analog signal is sampled. The analog signal is sampled every TS seconds. TS is nothing but sampling interval. Okay. So before doing this sampling, so we need to we need to know the sampling interval. Okay, at what interval we need to sample the signal. Okay, here Fs is equal to 1 by Ts is called the sampling rate, or sampling frequency. Also, it is also we call it as a sampling frequency. Okay, and in the sampling we have different methods are there. So one is ideal sampling, natural sampling, flat top sampling. There are this different sampling in the different methods in the sampling. Okay, ideal is nothing but impulse is sampling instant. Natural is a pulse of short width with varying amplitude. Flat tap is nothing but a sample and hold like natural but with single amplitude value. Okay, these are all the different methods in the sampling. Okay, so that process is referred as a what you do the sampling process. Okay, that complete process is normally referred as a pulse amplitude modulation process, or it is also called as PAM, pulse amplitude modulation. Okay, the outcome is the signal with analog value. Okay, so after doing this sampling process, the outcome of the signal is analog value. It is a non-integer values actually after doing the sampling process. So next is, so this is the complete about the sampling process. How we are going to do the sampling? What are the different types of the sampling? Okay. So this is about the sampling. So next is quantization they are going to do. Okay. So this is the second step in the conversion of the digital signal from the analog signal. Okay. So how to do the quantization? Okay. What do you mean by quantization? Okay, so that we need to see in this uh, PPT. So quantization, okay. Sampling actually results in a series of pulses with varying amplitude values ranging between the two limits, minimum and maximum. Okay, sampling. Okay, you know already how the samples are considered in the analog signals. Okay, in that case, we will have the varying amplitude values. Okay, that is ranging between two limits. One is either maximum or minimum. So like that we will have in the sampling signal. Okay, so the amplitude values are infinite between the two limits. So infinite between the two limits is nothing but in the sampling signal. If you take consider the sampling signal, we have the infinite limits. Okay, so infinite we have the infinite between the two limits. So either maximum or minimum, either maximum or minimum, like that. Continuous fluctuation, continuous amplitude variation is available in the amplitude values. Okay, so we need to map these infinite amplitude values into finite set of the known values. Okay, so this is the process called as quantization. Okay, like this we have in the sampling signal. So we have the different limits. Okay, amplitude values keep on changing with the different limits, either maximum or minimum, like that. Continuous variation will be there. So to map these infinite amplitude values into the finite set of values. Finite set is nothing but some limited set of values. Okay, that is why we are doing the quantization. Okay, this is achieved by dividing the distance between the minimum and maximum into the L zones. Okay, so each of height delta. Okay, I will tell you what is L zones and the height of that delta. What is the delta? So in the coming picture. Okay, this is achieved by dividing. How we are going to achieve these infinite amplitude values into the finite set of known values by achieving by dividing the distance between minimum and maximum altitude variation into the L zones. Okay, each of height delta. The delta is given by delta is equal to maximum minus minimum divided by L. Okay, maximum amplitude level minus minimum amplitude level divided by L zones. So I will tell you what is L zones. Okay. Okay. Next is the quantization level. Okay. So these L zones are classified into different levels. L zone. That is why it is called as L. L is represented as a level. Okay. So the midpoint of each zone is assigned to value from 0 to L minus 1. Okay. Each sample falling in a zone is then approximated to the value of the midpoint. Okay, so this is I'm going to tell you in the diagram. Okay, so like this. Okay, these are called as different levels with the different height. Okay, this is the input output characteristics of the mid rise type quantizer. Okay, we have the different type of the quantizer, mid rise quantizer, mid thread quantizer. So like that we have different types. So this is one example of mid-rise type quantizer. Okay, here you can see in this quantization input-output characteristics of mid-rise type quantizer, we have the different level. So if you observe this red color, okay, this is one level. Okay, this is another level. This is another level. This is another level. So this is the height of the uh, level. Okay, delta, 2 delta, 3 delta, 4 delta. This is delta by 2, 3 delta by 2, 5 delta by 2, 7 delta by 2. So according to the input output characteristics, we have defined the different levels, level 1, level 2, level 3, like that, in a positive side and in also negative side. Okay, this is the leveling of the zones in the quantization. Okay, so then we have quantization error. Okay, so quantization error is nothing but, okay, when a signal is quantized. So quantized anta andre, if I decide this signal is either 1 or 0. Okay, either 1 or 0 depending upon the finite set of the amplitude values. Okay, by creating the different zones with different height delta. Okay, so when the signal is quantized, okay, during this process, okay, we have an error. Okay, we have an error because we have the variation amplitude of different levels with maximum amplitude, minimum amplitude. So within that minimum and maximum, we will decide the different zones. Depending upon that zones, we will make the decisions either 1 or 0. Okay, while doing these things, we will have the error. That error is called as quantization error. Okay, when the signal is quantized, we introduce an error. So that coded signal is an approximation of the actual amplitude value, because since we are doing the approximation in the quantization process by considering the different zones in the process, so we come across the quantization error. So that error is called as quantization error. Okay, so actually what is that quantization error? So difference between the actual and coded value is referred as a quantization error. Okay, here more zones. So how to avoid this type of the error antandre? So this can be avoided by creating the more zones. So more zones antandre, like this we need to create more zones. Okay, so if you do these more zones, there is a possibility of avoiding the errors. Okay, more zones, that results in a smaller errors. Okay, but more zones, if you use the more zones, then while decoding the signal, we need to have the more bits to encode. To encode the signal, we need to have the more bits. It is required more bits. Okay, to encode the samples. Okay, that leads to the higher bit rate. Okay, so this is about the quantization error. Okay, so this is the conversion, how to do this process anbuttu. So they will take the different level. Okay, so how? So this see, we in this sampling signal, we have 2.2 amplitude is considered as a 2-volt amplitude. So this is 2.8 something. So this is considered as a 3-volt amplitude. Like that, they are making the approximation. This approximation process is called as quantization. So like this they will construct. So we will assign the closest level. So this level is considered as a 2-volt level. Even though it is a 2.2 volt amplitude value, we will take the assign the closest value, closest level. So it is considered as a 2 level. So like that we will do. So this process is called as a quantization. Each quantization level corresponds to a unique combination of the bits. The analog signal is transmitted or stored as a stream of bits and reconstructed when it is required. Okay, like that. So see, using this sampling signal, we will make the digital signal. So this is considered as a 00. This is considered as a 01. This is 10. This is 11. This is 10. This is 01. This is 0. Okay, if you put more zones, then it require more number of the bits to represent the digital signal. That leads to higher bit rate. Okay, so like this we are converting the analog signal into the digital signal by the process called as the quantization.